Hey guys, how's it going? Thank you everyone for coming out today and participating for the EigenLayer presentation. We're super excited to have a conversation today and present some information about where we're at in terms of our mission, our roadmap, as we mentioned, enabling new projects to be able to borrow security from Ethereum restakers, enable the Ethereum operator community to participate in validating and essentially bootstrap these new protocols. So let's start by kind of going over an overview of where we're at in terms of the goals of EigenLayer and what we really set out to accomplish. So we saw in the last few years, plenty of protocols started deploying their own tokens to determine their own security, right? And what that actually led to was innovation leaving the Ethereum ecosystem. As you saw, new L1s come, new L2s all launch their own tokens. L2s were at least able to borrow the security from Ethereum because Ethereum becomes the de facto settlement layer. But the reality is, a lot of the value extraction was moving away from Ethereum, and the innovation as a result was moving away. So at EigenLayer, we viewed Ethereum as the public commons and kind of the center of innovation and economic activity. So we wanted to come up with a solution that would enable, Ethereum protocols to be able to bootstrap themselves faster, but also protect themselves from the reality of debt spirals. When you have projects that have security that's determined in their own token, when you need security the most is when it will fail you, which is the definition of the weakest link in the chain. So rather than using your own token just for security, we wanted these protocols to use their token for rewarding users, incentivizing participation, also governance, but your security should be borrowed from the Ethereum community and be bootstrapped by the Ethereum community. So the values of decentralization. So let's just look at applications today, right? Applications, the average Web 2 application is comprised of like 10 to 20 SaaS modules. And yet, the reality is the majority of those modules are extracted away from the end user. When you interact with payments, you're more often interacting with something like Stripe or some back-end tool that's doing the payment processing. When you're doing login, you're dealing with OAuth or any of those services. But the end user does not experience any of the friction. It's all abstracted away. So we wanted builders to start experimenting again, as I mentioned, and bring that innovation back to Ethereum because the entry cost of capital to build a protocol became so high. And so how do we create an ecosystem that has Ethereum native value distribution as well as development? There's a lot of projects that can create value. There's some that capture value that sometimes becomes extractive. But the reality is we want projects to be able to create, capture, and redistribute value. And what does that look like? Is, in our mechanism, it's paying out to the Ethereum restakers and operators, but also it's incubating a ecosystem of builders that will be able to support your protocol for a longer period of time. And you have not just like short-term use cases that are filled, but also long-term incentive compatibility to enable these projects to stay long-term. So crypto brings these native incentives, user governance, and the most important thing, permissionless innovation, right? What other industry do you have the ability to just build and deploy and take an idea that starts off, take EigenLayer ourselves, right? We're a 30-month-old company, and we went from a bunch of researchers working in a lab. I was not a researcher, full context. So a bunch of PhDs and myself working in a lab for 8 months in stealth, going from a project that was just a sheer idea to now a restaking protocol that has 10 AVSs live with nearly over 4 million ETH that's being restaked, and there's the ability to permissionlessly innovate and execute without needing centralized parties to be involved. And so you have essentially a demand for converting today. And our end goal is to eventually start converting more and more applications that are currently being built on the cloud to being able to be built on Web3. And so we essentially look at, like, there's like a lot of applications today in crypto that are predominantly DeFi, order book dexes, NFTs, et cetera, that have a demand for very high security, but don't necessarily have a demand for throughput, right? Throughput, network latency, bandwidth, these are all attributes of what protocols need to be able to enable more intricate use cases. Now, an example of those use cases, like what would it take to, a question we like to ask ourselves is, what would it take to port over 5% of Web 2 applications to Web 3? What would the infrastructure have to look like? And the reality is it's heavily dependent on the use cases, because some use cases value and attribute security very highly, and some value throughput very highly. And that comes around this metric called value per bit. If you take out the transaction value, divide it by essentially the amount of bits per transaction, you can achieve this metric that looks at, hey, for example, gaming doesn't necessarily, on-chain gaming specifically, doesn't necessarily have a lot of embedded value in each transaction or in each bit, but the law of large numbers will apply, and you can see that the aggregate value of gaming could be very useful long-term. An example of this is, let's just say, I'm playing chess with someone, and we don't necessarily need to write every single state update of each move of each player to the L1, right? Writing on Ethereum is extremely expensive. Writing on, and there's not necessarily a lot of embedded value in each of those transactions, but there could very easily be a secondary market that's contingent on the result of that game that is betting on myself and the other player and needs L1 finality to be able to settle that betting market. And so now all of a sudden, the state updates weren't necessarily of high value, but the end result of the game became much more valuable. This could also be applied to on-chain social, where let's ask the question, what's the value of posting a picture today of my pizza on my Twitter versus my Farcaster or my Lens? We might not see that today, but long term, we can see the value of building these new native communities that exist on these new protocols. And so the question becomes, cloud applications needed high throughput, but the reality is crypto applications need this infrastructure to be built so that we can eventually support new use cases downstream. And so EigenLayer is designed for building a shared security platform where all of that innovation can be brought back to the Ethereum community, and they can repay Ethereum stakers and operators to be able to support this innovation. But also, the amount of restaked is, the value of restaked is applied to all of these services. Rather than fragmenting security, where in a modular ecosystem, every module has its own security component, and now you're only as weak as the security of the weakest module, you have this aggregation, or like essentially this hardening effect of security, where it's much more difficult to corrupt $20 billion staked versus $200 million staked, right? The cost of corruption must always outweigh the profit from corruption. That's one of the core mechanisms by which you want to be able to enable this. And so you essentially can buy a certain amount of slashed stake to be able to protect insurance, to be able to protect yourself from these slashing conditions, which is how attributable conditions where projects misbehave can be applied, and enables a robustness of the security. And so each of these services go about building their own slashing conditions, and the slashed funds will be used to be redistributed to the ecosystem. And so now you can use EigenLayer, and eventually we will have Eigen Insurance specifically, but you can think of this as an insurance module for attributable security. And so we can achieve a certain levels of economies of scale in insurance, because if an app uses 5 services, all of which are fully restaked, then the aggregate security becomes much more robust rather than the individual security of each. And so, right, you end up with this scaling ability for security. So we want to enable this cloud era of crypto. And what does that look like, right? EigenLayer becomes the baseline shared security system, and you can build essentially this plethora of services and bring the innovation across all these layers. So we see that the end game to scaling in Ethereum has moved to rollups. And we have optimistic and ZK rollups, and we're starting to see different strategies across both. But the reality is that's just one attribute of how scaling needs to work. And we need to build a lot more modules to build a lot more robust scaling ecosystem. So what does that look like, right? We have bridges, we have MEV services, but a couple of the AVSs that are building are doing decentralized sequencing, shared sequencing. We have watchtower networks. We have projects who are building VM co-processors. So what can we do to deploy Web 2 applications natively using co-processors or compilers to be able to port applications much faster from Web 2 to Web 3, right? What does it take to build far more robust cryptography methods, whether it's trusted execution environments, fully homomorphic encryption? And the reality is all of these projects would go about innovating in their own ecosystems, in their own silos, but we can aggregate them and bring them all to the Ethereum community, thereby increasing the robustness of all these scaling solutions across Ethereum. So there's a certain elegance to the solution where Ethereum becomes the public commons for innovation, whereas each of these projects can go ahead and build their own individual ecosystems and build a far more robust system. So we're starting to see a bunch of applications that are being built, and you see underneath EigenDA and EigenCert, those are specifically applications that we're building internally. EigenDA is a data availability service that is focused on scaling throughput for the Ethereum ecosystem. We're at 10 megabytes per second today, and our goal by the end of 2024 is to reach 100 megabytes per second. We have some goals eventually to be able to scale to 1 gigabyte per second by increasing the operator set that participates and keeping the per node footprint very minimal. So yet again, you can ask yourself, what are the use cases that get enabled by 1 gigabyte per second throughput on decentralized systems, right? Let's imagine you could eventually host a fully on-chain game actually, let's take it a step further, right? We could host the World Gaming Championships of a fully on-chain game on a fully live on-chain streaming service with a live secondary betting market that's all settling instantly, all based on this 1 gigabyte per second throughput capability. So, and that's the reality of the internet that we all experience today on Web 2. If you're watching the World Dota Gaming Championships, for example, with a $150 million prize pool, right? Why do we experience any of the frictions that we do in Web 3 today on Web 2? The reality is the infrastructure is so robust that we can all get to experience the benefits of this, right? And so we want to enable just a fraction of these use cases at some point on Web 3, and so the infrastructure must precede this. EigenCert is a far more technical and specific use case for signature aggregation on Ethereum. The cost of BLS aggregate signatures gets really expensive when projects are required to sign and prove that they were storing some data or doing some actions. And we want to build a service that not only helps us scale that operator set for EigenDA, but also enables all other rollups to be able to use this and scale, or go expand beyond the rollup ecosystem and the AVSs, these actively validated services that are building on the shared security system to be able to scale. And so, eventually, I briefly had this custom staking thing on the previous slide. Let's see if I can go back. Lovely. So right now we have Ethereum that's being restaked to support all these protocols, but eventually what we want to enable is custom staking. So rather than just paying for the security in ETH, you can eventually pay for the security in ETH equivalent emissions of these individual tokens. So what does that look like, right? Let's just say rollup A is using EigenDA and they need to pay for DA gas fees. And currently those DA gas fees are denominated in ETH. The rollup might be launching a token, and those tokens might have a certain value, and so we can essentially attribute, with that 100 megabytes per second, we can fractionalize that into reserved bandwidth instances similar to AWS. And now you can have very specific bandwidth certainty and price certainty of what your DA fees are going to look like. So you're no longer fluctuating to the gas of Ethereum, but also you can now pay for that in your own token rather than paying in ETH. And it would just be the equivalent. So we want to enable these high modality systems to exercise subjectivity. There's objective faults and there's subjective faults, right? objectively attributable slashing is where we can identify a clear party that's misbehaving, and we can directly slash them. Now, subjective slashing becomes far more interesting and far more difficult to do because it involves social consensus. And we've run into issues along that in various parts of the Ethereum ecosystem, but now we're starting to see some potential solutions that we want to tackle that with, and you'll be seeing that in the next couple of weeks, next couple of months from the Eigen team here shortly. So yeah, we just launched on mainnet. It's been a crazy journey, and now restakers can delegate to an operator of their choice, and operators can register and opt into specific AVSs. The AVSs are an actively growing, diverse set of projects, and they're we're actively expanding those sets of AVSs. We have 8 to 10 of them that have gone live already. We have a bunch in the pipeline. Shout out to our AVS ecosystem team that's actively growing and incubating these. We have projects that we're building for the last few years and recognized that EigenLayer could be a security as a service module for them, so they've adopted the EigenLayer standard. And there's also projects that are native, homegrown, incubated AVSs that we've taken a lot of time to involve ourselves in the protocol design even. And so, interesting, we don't have the list of AVSs that are live, but off the top of my head, Omni, Lagrange, Near, Witness Chain, these are all protocols that are actively deploying right now. So Witness Chain, for example, a watchtower network like I mentioned earlier, Omni and interoperability protocol. We're actively seeing bridges, a lot more solutions that are coming live into the ecosystem. And so kind of going back to converting cloud to crypto and emphasizing this need for consumer use cases, we're starting to see the rise of a lot of app-specific use cases, because the reality is, like I said, users can be abstracted away from the end user experience of crypto. Users don't necessarily need to know that this is happening on the back end. Similarly to how a lot of SaaS modules you're interacting with, but you don't even recognize. And so sequencers on rollups can give instant confirmation for app-specific rollups, so now you can behave very similarly to a Web2 centralized ecosystem. You have general purpose VMs, so eventually we could deploy games and VM co-processors that will enable the porting of games nearly with far less development work required. And we can eventually do gasless, no wallet usage for authenticated users. We can introduce KYC, and we can introduce far more interesting, robust security modules that enable a future of crypto that has far more consumer use cases. Because the reality is right now, we have a lot of DeFi, we have a lot of NFTs, order book dexes, but we're just starting to see the market of on-chain gaming, on-chain social enter. So there's a lot of interesting things that we can do with exactly composability, where we have the security that comes from EigenLayer, as well as the rise of LRTs, liquid restaking tokens, that enable far more liquidity options for these AVSs to be able to deploy native liquid staking tokens far more quickly, or to be able to bootstrap themselves on day one with X amount of security that's bootstrapping their protocol. So, I want to touch a little bit on some of the problems today, but we can go a little further into what are the dominant costs, right? There's shared security, which is the security as a service, which will reduce the capital costs of entry. Rather than these projects having to go out and bootstrap their own tokens and create their own, market cap for security, paying for security as a service, similar to compute as a service, is a far more scalable model for enabling the ecosystem much faster. Right? Better distributed systems, things like EigenDA, which have much more throughput, where the per node footprint is far more minimal, reduces your operating costs dramatically. And then, right, we talked about reservation. We can reduce congestion costs. We can eliminate gas as a concept. And the reality is, blockchain developers today are restricted by block space. They're restricted by throughput. And they've been building for so long that to some extent, the creativity gets limited by the inherent limitations of the ecosystem. So if there's one thing that I want the crowd to think about is, what are the use cases that you could build on crypto when block space is no longer a limitation? What are the use cases that you can build when gas fees and constant fluctuation is no longer adding price uncertainty to your costing? And so these projects can have far more robust forecasting of their security, their costing, their operating costs. And so you have a much, much lower lift to be able to come and enter the ecosystem and build. Right? Classic. You only have a certain amount of money that you want to attribute to security or your compute or specific attributes. And so you want to make sure that you're not limited by the resources. I know we're running low on time here, so I want to skip through because I've already touched on some of this. But yeah, we want to enable these L2s to be able to eventually outrun L1s, because the reality is today, rollups don't have the block space that enables them. They don't have the price uncertainty. They don't have the exchange rate risk because they can't necessarily they have price attribution between their rollup native token and ETH. And so by enabling these custom staking models and things like that, we want to enable a far more robust security platform to EigenLayer. So EigenLayer is focused on enabling shared security and bringing these new services to rollups. And we can really go beyond the space of just rollups with oracles, keepers, ZKP, FHE. We talked about a few of these things. So the end game is, what would we build if block space wasn't a limitation? What would we do if security was no longer the barrier? And now that you're no longer worried about the constant debt spirals and the limitations of your own ecosystem, and you can drive this innovation back to Ethereum, how do we drive Ethereum to be the center of economic activity for the next foreseeable future and make an actual dent in the adoption of crypto and Ethereum as an overall entity? Thank you very much.